So this is day one. The question that we want to answer is, what does an LLM actually do? So it just does one thing, which is to predict the next word. That's it. That's the reason it's also called the next word predictor. So for example, if we type the sentence, the cat sat on the whole job of the LLM is to predict mat. Then it takes the whole sentence, including the mat, and predicts the next word again, which would be full stop in this case. And it does it again and again, thousands of times, until you get the full response. That's literally how the ChatGPT responds to you. So if we can understand how this next word prediction happens or work, we basically understand how LLM works. So the whole architecture behind this is the famous architecture called Transformer, which was built by Google, and it was built for Google Translation but later carried out for the LLMs. So there are three parts to this transformer architecture. The very first one is the input layer, then the transformer block, and the output layer. So let's just focus on the input layer for this video. Three things happens into input layer. First, we basically provide the sentence, and as we know, we human can understand English, but computers can understand only numbers. So what happens is that your sentence gets split into tokens. For now, just think each of the words as one token. The cat sat on this becomes 5 tokens. We'll go deep on how tokenization works and what exactly the algorithm behind this. Second, each tokens get converted into a list of numbers called an embedding, a 768 dimension vector to be exact. So think of this as each dimension is asking a question about the word. Is this a noun? Is this an animal? Is this a verb? So cat scores high on animal. That's how basically the meaning get captured in numbers. So if you look at this graph, the cat and dog end up similar vectors because they both are animals. But here's the problem. If we read the sentence, the dog chased another dog, we humans can understand which dog has been chased here. For the LLMs, it might be confusing because both the vectors of dog are exact same here. So how does it know like which dog is chasing and which is running? That's where the third step comes in, positional encoding. You add another vector that tells the model where each word sits in the sentence. Now both dogs are different, same word, different position, different meaning. So token embedding plus positional encoding, that's your input embedding. That's what basically passed into the transformer.